Hello mathematicians. In this video, we're going to continue building up our intuition for geometric reasoning by studying the attributes of quadrilaterals. First, let's talk about some geometric terminology. Terminology is a specialized vocabulary that applies to a particular subject. In geometry, like a lot of math and science, much of the terminology derives from Greek and Latin. So it's helpful to know some of that etymology or word history. Geo comes from a Greek word meaning earth. Metric comes from a Greek word meaning measure. So the word geometry means earth measurement. One of the main reasons that the ancient Greeks were interested in mathematics is that they wanted to be able to measure the earth as well as the planets and stars they could see in the sky. Poly comes from a Greek word meaning many. Technically, when you see poly, you know that it means more than two. Gon comes from a Greek word meaning angle. So the word polygon means many angles. A polygon is a geometric figure with more than two angles. Tri comes from a Latin word meaning three. So a triangle has three angles. You will also sometimes see a triangle called a trigon, a trigon. Trigon and triangle mean the same thing, a geometric shape with three angles. Quad comes from a Latin word meaning four. Lateral comes from a Latin word meaning side. So a quadrilateral is a geometric shape with four sides. In this video, we'll be investigating the attributes of quadrilaterals. A quadrilateral is a closed figure that's formed by straight line segments connected at corners or vertices. So what's the first attribute of a quadrilateral? It's a polygon, a closed geometric figure with more than two angles. Actually, we've already seen that a quadrilateral has four sides, and we know that if it has four sides, it must also have four angles. The interior angles of a polygon are the angles inside the polygon. Corresponding to each of these interior angles is an exterior angle, the angle outside the polygon. In the last video, we saw that the interior angles of a triangle always add up to 180 degrees. What do you think the interior angles of a quadrilateral add up to? Pause the video and think about it. If you're working with someone, talk about it. The sum of the interior angles of a quadrilateral is always 360 degrees. You might make a note that this is similar to a circle. In a circle, there are 360 degrees. The four interior angles of a quadrilateral always add up to 360 degrees. What are the attributes of a trapezoid? A trapezoid is a closed geometric figure with four straight line segment sides and four angles. So a trapezoid is a quadrilateral. Because it's a quadrilateral, it's also a polygon. So a trapezoid has all of the attributes of a polygon and all of the attributes of a quadrilateral, and it has exactly one set of parallel sides. In the diagram, we mark the parallel sides with these small arrows, which are sometimes called wings. So when you see a matching pair of wings on a geometric figure, you know that they're indicating that those sides are parallel. It's important to know that in some geometric systems, a trapezoid is defined as having at least one set of parallel sides. However, for our purposes, we're going to define a trapezoid as having exactly one set of parallel sides. So if a trapezoid is a quadrilateral with exactly one set of parallel sides, what are the attributes of a parallelogram? A parallelogram is also a closed geometric figure with 4 straight sides and 4 angles, so a parallelogram is also a quadrilateral. Because it's a quadrilateral, it inherits all the properties of a quadrilateral and also all the properties of a polygon. In a parallelogram, the opposite sides are parallel. The single wing on this side and this side indicate that these opposite sides are parallel. The double wing on this side and this side indicate that these opposite sides are parallel. You might notice that a parallelogram sort of looks like a tilted rectangle. It kind of looks like someone squished a rectangle. Part of the reason that a parallelogram looks like a tilted rectangle is that the opposite sides are not only parallel, but also congruent. The single hash mark on this side and this side indicate that those opposite sides are congruent. The double hash mark on this side and this side indicate that those opposite sides are congruent. They have the same length. Once again, it's no accident that the opposite sides of a parallelogram are congruent. They are congruent because a parallelogram is a quadrilateral with parallel opposite sides. Just a reminder that at this point we are only building up our intuition for these relationships. In future geometry classes, you will learn how to construct a proof that the opposite sides of a parallelogram are congruent. Now let's think about the angles of the parallelogram for a minute. Can you make a prediction about the angles of a parallelogram? Pause the video and think about it. If you're working with someone, talk about it. See if you can make a prediction about an attribute of the angles of a parallelogram. Because the opposite sides of a parallelogram are parallel and congruent, opposite angles are also congruent. This single arc and this single arc indicate that these opposite angles, these angles that are on the other side of each other, are congruent. They have the same measurement. This double arc and this double arc indicate that these opposite angles, these angles on the other side of each other, are congruent. They have the same measurement. We know that this angle and this angle are not congruent. They don't have the same measurement because this angle is marked with a single arc and this angle is marked with a double arc. We call these angles consecutive angles. They're consecutive angles because they're next to or adjacent to each other. Now here's a real thinker. Can you make a prediction about consecutive angles of a parallelogram? Pause the video and think about it or talk about it. See if you can make a prediction about the consecutive angles of a parallelogram. Consecutive angles of a parallelogram are supplementary. Do you remember what supplementary means? It means that they add up to 180 degrees. So this angle plus this angle would equal 180 degrees. This angle plus this angle would equal 180 degrees. This angle plus this angle would equal 180 degrees. This angle plus this angle would equal 180 degrees. Consecutive angles of a parallelogram are supplementary. They always add up to 180 degrees. So a parallelogram has many interesting attributes. Because a parallelogram is a quadrilateral with parallel and congruent opposite sides, its opposite angles must also be congruent and its consecutive angles must be supplementary. These are more geometric relationships that you will learn how to prove in future geometry classes. If a parallelogram kind of looks like a tilted rectangle, it might be interesting to think about what are the differences between a parallelogram and a rectangle. But first, let's think about what they have in common. What's the most important thing that a parallelogram and a rectangle have in common? They are both quadrilaterals. Now, what makes a rectangle different from a parallelogram? A rectangle must have exactly 4 right angles. In the diagram, we note a right angle by placing a small square in the corner where the angle is located. We can see that in this quadrilateral, all 4 angles are right. They measure exactly 90 degrees. And because all 4 angles are right angles, a rectangle must be a parallelogram. Often you will see a rectangle defined as a parallelogram with exactly 4 right angles. But actually, if we know that a quadrilateral has 4 right angles, then we can prove that it must be a parallelogram. So the fact that a rectangle is a parallelogram comes from the fact that it has exactly 4 right angles. What else can we predict about the sides of a rectangle? Pause the video and think or talk about it. See if you can make another prediction about the sides of a rectangle. Because a rectangle is a parallelogram, because its opposite sides are parallel, they must also be congruent. However, it is possible to prove that a rectangle has exactly 2 sets of congruent sides directly from the definition of a rectangle as having exactly 4 right angles. So the fact that a rectangle's opposite sides are parallel and the fact that its opposite sides are congruent can both be proved from the definition of a rectangle as having exactly 4 right angles. Because geometry is all about relationships, and there are so many relationships in geometry, we can often prove the same fact in more than one way. What are the attributes of a rhombus? The first attribute of a rhombus is that it's quadrilateral. It's a polygon with 4 sides. In addition, all 4 sides of a rhombus must have the same length. A rhombus must have exactly 4 congruent sides. In the diagram, a single hash mark on each side of the rhombus shows that the rhombus has 4 congruent sides. We have already seen that the fact that a rectangle has 4 right angles is sufficient to prove that it's a parallelogram. It turns out that having exactly 4 congruent sides is also sufficient to show that a quadrilateral is a parallelogram. This fact allows us to make a prediction about the angles of a rhombus. Pause the video and think or talk about it. See if you can make a prediction about the angles of a rhombus. The opposite angles of a rhombus are congruent. In the diagram, this single arc and this single arc show that these opposite angles, these angles on the other side of each other, are congruent. This double arc and this double arc show that these opposite angles, these angles on the other side of each other, are congruent. However, this angle and this angle are not congruent because this angle only has 1 arc and this angle has 2 arcs. Do you remember what this pair of angles is called? These angles are consecutive. They're next to each other. And because a rhombus is a parallelogram, it inherits all of the properties of parallelograms, which means that its consecutive angles are supplementary. They add up to 180 degrees. Finally, let's investigate the attributes of a square. A square is the last quadrilateral that we'll investigate in this video. There are two essential elements in the definition of a square. The first essential element is that a square is a rectangle. That is, a square has exactly 4 right angles. We know that this polygon is a rectangle because each of the 4 angles is marked as right. We have already seen that having 4 right angles is sufficient to prove that a quadrilateral is a parallelogram. So a square inherits all of the properties of a parallelogram from the first part of its definition, as well as all of the properties of a rectangle. The second essential element of the definition of a square is that it is a rhombus. A square must also have exactly 4 congruent sides. We have also seen that this part of the definition alone would be sufficient to prove that a square is a parallelogram. So a square is kind of a double parallelogram because either of the 2 essential elements of its definition would make it a parallelogram. Because a square is both a rectangle and a rhombus, it inherits all of the properties of both of those shapes. And that makes it a very special kind of polygon. Do you know what kind of polygon a square is? A square is a regular polygon. A regular polygon is a polygon whose sides and angles are all congruent. It is equilateral and equiangular. All of the sides are the same length and all of the angles have the same measurement. So mathematicians, that concludes our investigation of the attributes of quadrilaterals and the second part of our introduction to geometric reasoning. In the next video, we'll start looking at a convenient and powerful way to represent geometric relationships visually.